Hello, my name is Anthony Benson, and this presentation is titled Network Graph Analysis, Email Network Display and Breach. In this project, I used Tableau to visualize three different email network data sets to analyze communication patterns, key connector nodes, and potential security vulnerabilities. The goal is to understand how information flows through each network, identify important nodes using between the centrality, and evaluate how each network will perform during malware infection or device failure. The Network 01 dataset represents a small, highly centralized email communication structure. The visualization shows a star-like pattern where most nodes connect through one central node. This makes the network simple and efficient, but also extremely fragile. Because communication depends on a single hub, it creates a clear single point of failure. If the central node were infected with malware, the entire network could be compromised quickly since all messages pass through it. If that device went down, communication between other users would likely stop completely. Overall, this network is efficient but not resilient or secure. The Network 02 dataset is a distributed and complex communication network with many interconnected nodes. Unlike Node 01, it does not rely on a single central connector. The dataset shows multiple key nodes, including Spectre, Stealth, and Shadow, which have higher between the centrality and help maintain communication flow across the network. I would describe this data set as moderately robust rather than fragile. If one node became infected with malware, the network would likely continue functioning because messages could reroute through alternative paths. Similarly, if one device went down, communication would still get through due to the redundancy of communications. However, high centrality nodes should still be monitored closely because they control significant portions of information flow and could become strategic risk points. The Network 03 dataset shows a highly centralized hub and spoke structure. The node nebula has the highest between the centrality, followed by Starhawk, meaning those nodes control most communication pathways. While this structure improves efficiency, it introduces major security risks. If the Nebula node were infected with malware, the breach could spread rapidly throughout the network. Additionally, if this central device failed, the network would likely become fragmented, causing delays or complete communication breakdown between peripheral nodes. This makes Network 03 organized but highly vulnerable. In conclusion, Network 01 is the most fragile due to its single point of failure, while Network 02 is the most resilient because of its distributed structure and multiple communication paths. Network 03 is efficient but highly centralized, making it vulnerable to malware spread and node failure. My recommendation to the client is to adopt a more distributed structure, similar to Network 02, implement monitoring for high between these nodes, and add redundancy to reduce resilience on central connectors. This approach would significantly improve both cybersecurity, resilience, and communication reliability across the organization.